Now, we finished the last video and we're actually talking about the families which we find in the periodic table and how they relate to the valence number of the electrons which make up these families. And so, just like you have the specific valence of these families, you're going to have different activity levels or different ways that these things are going to be. Every single person in the first family is called an alkali metal. Now, alkali metals are, in the first column periodic table, they tend to be shiny, soft, silvery, and very reactive elements, and they're all looking to give up one electron. Now, everybody is included in the family except for hydrogen, which is actually a non-metal, okay? And the only reason he's on the first column is because sometimes he has metallic-like properties, and because it only has one electron as the last shell. But it's actually a different kind of thing. Remember, hydrogen and helium are exceptions for the rest of the periodic table, okay? Now, on the second column of the periodic table, you're going to have, or alkaline earth metals. And just like the metals, they're also going to be reactive. A little less reactive than the alkaline metals, but they're also going to be reactive, and they're also going to be metallic in nature. They're going to look like that, and it includes a lot of different things, including famous things which are common in the Earth's crust: calcium, magnesium, radium, barium, and so many other elements. Okay? Now, helium has 2 electrons in its last shell, so it's occasionally considered to be here, but in most cases, because it has a completed shell, it's actually put along with the noble gases, okay? But alkaline earth metals are usually including everybody from beryllium and down. That's our alkaline earth metals. Now, everybody in the group that starts with boron is actually called the boron group. Now, they all have 3 electrons in their last shell, and they tend to want to lose them, with a few exceptions in some circumstances. Now, they are called poor metals, or some of them are even called metalloids, because they actually act a little bit like non-metals in some circumstances, but they include famous elements, including aluminum and boron. All right. Now, these are sometimes also referred as earth metals, and you can see how they look like there, and they're going to be a little softer in most cases than the other metals of the transit metals which are in between them. All right. Then you also have the carbon group, and the carbon group is the next group of the periodic table. And now you're trying to get to the point that these things are not acting as metallic as the other ones we talked about before, and they will include famous things like germanium and tin and lead, okay, and silicon. Now, as you go down into the bottom, it's going to be a little more metallic, but carbon and silicon are, most people consider them to be either non-metals or metalloids, okay, so depending on how you look at it, and so they are going to but everybody in this will actually have 4 electrons on the last shell. Then you have the next group, and that's called the nitrogen group, and the nitrogen group will include very famous and very reactive elements, which include nitrogen and phosphorus. And then you have some metalloid-like elements like the arsenic and bismuth and other things like that. And you also have the recently discovered element 115, which hasn't been named yet because it hasn't been stabilized as well yet. Okay. Also notice that on the previous groups, the carbon group and the boron group, you also have undiscovered or unnamed elements already. Now notice that the ones marked in green here are going to be our non-metals. So carbon, nitrogen, phosphorus, oxygen, sulfur, and selenium are all classified as our basic non-metals. The poor metals are going to be things like aluminum and all the ones marked in gray. And then you're also going to have the metalloids, which are in between metals and non-metals. And those are the ones marked and put in this kind of tannish color there. Okay? Now, then you're also going to have our oxygen column here has a special name. Now, in the oxygen column, it's called the chalcogens, and they tend to be non-metals, and they're very, very reactive, including oxygen, sulfur, and selenium. Very famous elements as well. And then you're going to have the next one, which is going to be your halogens, which are the most reactive elements in the periodic table, especially the ones which include fluorine, chlorine, and bromine, and also iodine. Now, you're also going to have, after that, the noble gases on the right side of the periodic table. Now, in chemistry class, you'll learn about the properties of these families in a little more detail. But I just want you to know that there are families, and that each family, what they have in common is the number of electrons that they have in the last shell. And whether the elements act one way or the other, it's kind of like different. Most people do not actually recognize people on the carbon group, for example, as one big family. Because you see, carbon is a nonmetal. And then you got silicon and germanium, which are metalloids. And then the other ones are poor metals. And so you see that you have different kinds of elements all within the same family. But everybody in that family will have the same number of electrons on the last shell. Now remember, of course, very important that the noble gases are going to be the least reactive elements in all the periodic table, and those are the ones in the extreme right size, and they're going to be very less reactive because they have completed shells and they don't really care to react with any other thing. And that's why they're actually gases. They have very close interactions even with themselves. Now, in this picture, you see some of the major metal families which we'll find in between the alkaline earth metals and the boron family that we actually saw before. And these are including groups 4, 5, 6, 7, 8, 9, 10, 11, and 12 of the periodic table. And you'll find several very famous atoms. You're going to find things like copper, zinc, gold, and silver, and the only liquid metal which is going to be, or mercury. You're going to find iron, you're going to find manganese, cobalt, titaniums, or and all of the different kinds of these elements. And so now we call these the transition metals because they're the ones which we're going to find in that D block of the periodic table, and they will have variable valence, and that's going to depend basically on the specific electron structure of these specific metals. And they'll form different kinds of bonds too. They will form metallic bonds, and it will act completely different from the way that the other metals like the alkaline and the alkaline earth metals actually happen, because they will not be as reactive as the alkaline earth metals are. You're also going to have, remember that these things are going to be in between those 8 columns that we talked about before, and that these 8 columns, the pattern you see and what makes them families is the fact that they have the same number of valence electrons in the last shell. First column has 1, second column has 2, so all the alkaline metals have 1, all the alkaline earth metals have 2, all the boron family has 3, carbon family has 4, nitrogen family has 5, oxygen family has 6, the fluorine family, which are called the halogens, have 7. The oxygen family is also called chalcogens with 6. And then you have the noble gases, which have completed shells with 8. And remember that this is going to determine the way these things react. Now, everybody that is on the halogens family is going to be tending to gain electrons to become like noble gases. Then the nonmetals, which are here in green, on families 4 through 6 are going to tend a tendency to take electrons to become like nonmetals as well. The family 4 will take 4, the family 5, nitrogen and phosphorus will take 3 each, and oxygen, sulfur, and selenium will take 6 each. Then you have the metalloids, and then they will sometimes act like metals and sometimes act like non-metals. Then you have the poor metals, aluminum and other ones in gray here. And then you have the post-transition metals as well. And you're also going to have the alkaline earth metals, which are going to be the most reactive. Now, that's the basics of the families of periodic table. And the only reason we put these elements in families is because they're vertically within a group that has similar characteristics in the sense of their formation of their electron clouds. So we'll continue talking about patterns of periodic table on the next video. I'll see you guys then.